So as the real world starts to move to this metaverse, inexpensive and ubiquitous sensing, it will become a must-have. And Somalytics and its paper carbon nanotube capacitive sensor seems to be a solution that may help kind of bridge this gap between the real world and the virtual world. And today we're going to talk to Barbara Barclay. She's the CEO of this new company and new invention, and we'll understand what it means. And Barbara, welcome to ViodiTV. Tell us about this 1 millimeter thick paper.
It is 1 millimeter thick paper as the sort of core substance that it's made of. Lots of people may not be familiar with carbon nanotubes, but essentially carbon nanotube is sort of 1/1000th the size of a meter. And a carbon nanotube is made of a sheet of carbon, which is an atom thick, rolled up, and then there are sort of multiple rolls, sort of like a hollow tube. If you had a microscope, you could see it. They're highly conductive, partially because they're shaped like tubes, so they have a large surface area. We mix them in a solution. We buy cellulose to make paper, combine the two together, and through a proprietary process, the carbon nanotubes get sort of baked into the paper, so to speak. And you have a sheet of paper that really looks like any other. It's a black sheet of paper, but it's highly conductive on its own. Then we slice it 1 millimeter thick in terms of the width, typically. Put a silver paste, which is a conductive metal, and wet it with an electronic wetting needle, essentially. And at that wetting spot, when you pull that apart, fracture the paper, you get kind of like a lot of fingers of cellulose. And each one, if you think about it, then has this incredible surface area. And so you combine the carbon nanotubes covering each piece of cellulose, and suddenly you have this very tiny area, but it's highly conductive. So it's a new type of capacitor. And a capacitor is, they're used in touch devices and all sorts of things, but they're typically pretty big. And you have to typically touch, like in a cell phone, for example, it's a touch capacitor. And then there's some that can sense proximity.
Okay.
And in this case, exactly. And in this case, it has multiple capabilities, but it's much, 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 much smaller.
So I probably shouldn't dive too deep into the technical yet, but I will ask you about, I'm kind of curious about how much capacitance, like, are we talking microfarads or whatever? But let's first talk about some of the applications, because that's where it gets exciting. So why don't you tell us some of these?
Like many things that are new inventions, it's the question of what to pursue because it has so many applications. But I would say chief amongst them is eye tracking.
And that's how we met.
Tracking. Yep, yeah. That's how we met. I've been in the eye tracking business for 11 or 12 years now. And the second application is really human machine interaction. So it might be a device that you're using, or it might be an augmented reality kind of environment. There's also industrial environments where they're using equipment to sense when something is full or not, or when someone is present or not. A lot of times they'll use cameras for that purpose. And then there's wearable sensors, and wearable sensors can really take on any form. You're familiar with, the Apple Watch or whatever it might be, but they are also, pretty commonly being invented right now. I wouldn't say it's perfect yet at all. Otherwise, we wouldn't have a spot. But they're, devices to monitor your heart rate, your respiration, your sweat, all kinds of things. And that's a definite application for what we're doing.
Well, so let's talk about the eye tracking one first, because I ever since we met, I've just found that to be so fascinating what the implications are. But you mentioned the paper, kind of is black. So the question is, is this something that's a type of thing where you can see through, or is it strictly for like not therapeutic? Well, I guess therapeutic and that sort of thing, or.
Yeah, it's a little mind blowing at first, even for me it was. So it's so small, right? It's only 1 millimeter wide and maybe 3 millimeters long. It's not too different from what you might see in current eye tracking glasses. So it'll take what we've determined today is 3 sensors, so one on each side of the eye and then one above the eye, and it in the proximity of the eye. So if you looked around, you would potentially sort of see it, but not really. You can embed it in the glass.
Okay. So that
Yeah.
protects it and keeps it in the same spot.
Exactly. Yeah.
And then do you have to bond it with wires or something? These little elements, do you have to bond them somehow to get them to, where your detection is, or how does that work?
That's a great question. So when we manufacture the manufacturing process for the sensor itself, after that fracturing occurs, so after you have this tiny little sensor, you wrap it in polyethylene.
Okay, a little plastic
tape,
casing, kind of,
to make it waterproof. If you're using it in a waterproof application, which typically you would, if you're using it as a sweat sensor band-aid, you might not, because you don't really care. It's going to be disposable.
Yeah. And so you have these little sensors there, and then is it just the eye movement? It detects the capacitance change of the eye kind of shape again?
Yeah, so you know your stuff. So
I don't. I'm just imagining how it works. This is incredible.
So obviously the capacitance is this electrical field, if you will, and the eyeball is also an electrical being, and so is human in general. Most of us are familiar with the electrical signals from the brain, like EEG, but people don't really think of sort of every other body part also having an electrical signal. And the eyeball, when it moves, is going to displace the electrical field, and then we can measure precisely what the eye is doing, left, right, up, down, by measuring that displacement.
That's incredible. And I would imagine one of the benefits, if you can get this manufacturing process down to where it's low cost, you can start to put eye tracking in a lot of devices. Is that kind of the correct thesis?
It is a great thesis. So the obvious application is sort of VR, let's say. And in VR, everyone wants to add eye tracking, and there have been some eye trackers added. If you're familiar with VR, it's usually because you want to make the experience for the user better right where they're looking, but you want to save on processing power. So you want to really not have to render this whole entire visual field in high definition. Eye tracking, by knowing precisely where I'm looking, could enable the manufacturer to only do what's called foveated rendering, or rendering it within about a 1 to 2 centimeter range. It also is considered really useful for sort of human interaction. So if I'm looking at you, you want to have eye contact with me in my avatar world. You need to know where my eyes really are, not where my head is. And so the problem is that the eye moves really fast, 500 degrees per second when you're doing what's called a saccade, or a rapid eye movement. If I'm darting around looking for people trying to get me in a video game, it's never going to keep up if it only takes 26 milliseconds to process my eye image, which is normal eye tracking, or it only has 100 samples in a second, and that'll give you a couple samples, not many, to know, hey, she just went from here to here very quickly. We need to know precisely where. And so
that's, I think one of your specs is 1,000 hertz or something.
Yeah.
So that's probably double what you're talking about there, right?
10 times.
Wow.
10 times. And in terms of that initial delay, because we're not processing the images of the eyes, that even a very rapidly processed image is going to take 25 milliseconds, something like that. Ours will take 2 to 3 milliseconds to shoot off a signal maximum. And so there's no delay. So now the brain, which would normally detect this sort of stuff going on in virtual reality, should theoretically be invisible.
I see. That makes sense. And yeah, the one application I've done with the eye tracking in VR, it was amazing, but it was the type of thing where it wasn't dynamic. All I was trying to do is hit a target. And without eye tracking, it was awful. With eye tracking, I looked like Nolan Ryan or something. And so that's a really cool application. Then do you see yourselves being as kind of that enabler of other people doing these things, whether it's for medical purposes, whether it's for entertainment, whatever? Where do you guys fit in the bigger scheme?
So I think your question is if we'll go directly to the consumer or the market.
Yeah, that's a good way to put it.
We will definitely be selling sensors to companies that are buying large volumes of sensors. But to be honest, I think we have a lot of value to add in the development of the products. And so our primary goal is to co-develop in the first instance, because we're a small company, and yes, we're funded, but there's only so much you can do in the first year or so until you have larger amounts of money through Series A or whatever. And so the way I envision it is it'll be a little bit of like an Intel Inside in the first couple of iterations of products that'll be predominantly directed towards consumers, but not necessarily. And then sort of once we get a couple of proof of concept products out there in partnership with other companies, I think we'll know a little bit more about what the next direction we want to head is. But I think that especially in the eye tracking area, I've been in the application of eye tracking for a long, long time. So I feel like we're in a unique situation, both in the sensor arena and the eye tracking arena, to find and recognize unusual applications for the technology that maybe if you're not so deeply involved, you might not think about it. And I think that might lead us to go straight to the market eventually for some products.
Sure, that makes sense.
Combination.
Yeah, I mean, you bring a unique viewpoint, given your your background, right?
Yeah.
A unique vision, I should say, pun intended. But so one of the other things that I find really fascinating is bringing interfaces to life on objects that otherwise might not have them. This touchless interfaces, whether it be an elevator button or whatever. Well, tell us a little bit about those things.
So today, especially after COVID, I'll use your example of a touchless elevator. There was a lot of talk about hygienic environments. Nobody wants to touch anything, and of course, a lot of the hand sanitizers and so forth are touch free. You probably noticed in the use of hand sanitizers or faucets that they require you to be extremely close. They're typically using infrared. And they're a little slow also, like, you stick your hand in there and then you pull it out and then it's on the ground.
Yeah. Right. That latency isn't good. Yeah.
Right. Especially if you're always in a hurry.
Yeah.
So in those environments, you could be farther away, but it would be also faster to respond. In an elevator environment, you could push all the elevator buttons as you wish, but never come near them. And you could do it in a very specific manner. In an elevator button, for example, you probably would, just because of the intuitiveness of it, want to be within a couple of inches of a button. But there are other applications where you might want to be farther away, or in the sort of wildly imagined, like in, I don't know, the last movie was maybe an Iron Man or something. You could have a glass panel where you're interacting with things, and it's maybe combined augmented reality, and theoretically that glass panel could have sensors embedded in it so that you could move your hands around, not necessarily wearing all the gear that most of the time people have to have on, but maybe those sensors that people wear on their hands combine with these types of sensors, or even maybe you wear some and some are embedded, but I think it serves a purpose because you don't have to wear it, and it can sense you in a pretty precise way when you're not touching it at a reasonably, big distance, which has never been done.
What is it, like 8-10 inches or something?
Right.
Yeah, so that's a decent amount. And then I guess what you're suggesting too is you'd combine your sensors, the input side of it, with some sort of display that projects, and so that's where you know where to point or whatever.
Right. And it has the capability to have, it's very precise. So in terms of your hands in the middle of the air, so to speak, I think that, once it's more advanced in terms of, the technology and both the algorithms that we're working on, that, for people who are used to sensors, I think I refer to it as sort of the precision of an inductive sensor, but the flexibility of a capacitive sensor, which are typically not that precise.
Well, that's interesting. So could you get kind of this analog feel almost then, where it's almost pressure sensitive, so you could, like increase the volume or whatever just by moving it closer, type of thing?
Yeah, that's the idea. In fact, the mat that we're working on right now, which we would hope to have at the Consumer Electronics Show, allows you to touch it, but would also allow you to, pound on it without, put your fist down and move your hand or use gestures. And in fact, you can actually roll it out on the ground, walk on it, and it can detect your gait. So
interesting.
Even gait analysis is a really big area in like when people have Parkinson's disease and other disease. They're really or visual problems. They can cause gait impact the gait, and a lot of times one of the main goals in a situation like where you have a movement disorder like Parkinson's is to predict when you might be a fall risk.
So this might even be embedded in a little shoe insert or something.
You could. So we've already talked about socks and shoes. In fact, I have a demonstration video that's, it's kind of a lab-related demonstration video, but you take your heel of your shoe and put it down on the sensor, and the sensor can detect the approach of the shoe as well as the impact of it and the pressure that's going on the heel versus the ball of the foot, for example.
Wow, that's exciting, because it gets into some of these predictive analytics and so forth to help people before they even know they need the help, right?
Right. One of my sort of favorite areas also, and it's kind of related to eye tracking and sensors, is sleep, where there's sort of this huge influx of sleep apnea detection devices that you can use at home, because lots of people have problems with sleep and it's very expensive to go into a lab, and lots of times your insurance doesn't even pay for that. So they have started doing tests at home, but in all these health related devices, the wearables, but also in sleep studies, one of the things that they don't typically know is your rapid eye movements, because your eyes are shut.
Okay.
Well, you could have an eye mask that detects your eye movements while you're asleep, and then would sync up with your wearable and really say, oh, did this person have the 5 cycles of REM that a person should have during the night, right, or whatever.
Yeah, and conceivably, it could be pretty low cost, because really you're just talking about your sensors and maybe storing the data and maybe a little processing. But then, like you said, you offload it to the smartphone that does the analysis and that sort of thing, right?
Yep. It's very inexpensive in terms of the cost of materials. Really, it's in, okay, what am I going to do with that?
Right. The data gathering becomes very inexpensive. And also from just a wearable standpoint, wearing a mask isn't, that obtrusive, right? An eye mask.
I mean, it's a pretty big area these days. People trying to block out the light,
Right. So do double duty. That's wonderful. And the nice thing from a privacy perspective, that it's not being automatically uploaded to some cloud. Yeah, that's exciting. Wow. And then in rural areas and places that don't have the same kind of medical resources, right? This would be such a godsend, it seems.
I mean, I do have a big imagination, but imagine if, every public school had access to glasses and they could just do a baseline. And when something happens to one of their kids, they put the glasses on, you walk around the school for the rest of the day with the glasses on, and the doctor can do a review with you at the end of the day.
And the fact that it becomes so inexpensive, and the fact that it's data that is transportable to other experts or machine learning programs, whatever, right? It's just amazing.
And I think that is the secret, is somehow making it sort of bulletproof in terms of use, Doesn't have to be complicated or doing really sophisticated things, and then making it cost effective. Because I've worked with public schools in the past, and they really want to help the kids, whether it's in reading or schoolwork, or to baseline the kids in terms of concussion. But a 45-minute test that you take when you're in the 9th grade before you go play lacrosse or whatever, which is what my kids had to do, you can game it. And it always comes down to eyes are eyes. You can't fake what they're doing. And if you are faking it, it's detectable.
In getting into the wearables a little bit, you mentioned something I had never thought of, and that is a Band-Aid that might have your material in it. Why don't you tell us about that application or your thoughts on it?
So there are a lot of wearable devices, and I think that are being invented right now. And I think the primary focus for people is in hospitals, intensive care, things where you have like a lot of people, but you don't really have time to monitor them all the time in the way that you should. And so, it can be kind of limiting. But I think because so many people are focused on their health at home and maintaining their health and managing it at home, whether they're, buying a, I don't know, bioimpedance scale. I have one because they want to know all the different components of their, muscles and bones and fat and whatever, or whether they're wearing a smartwatch. I think that the market at home of people who take care of themselves and monitor themselves is incredible. And I think that one of the things that gets in the way of people doing things at home is cost. And, today, if you have a stroke, your doctor might send you home with a device that they put onto you, and then they monitor your heart rate for 2 weeks to look for issues. What if after a stroke, you could also monitor your eye movements while you're walking around the house with a pair of glasses that were disposable, that uploaded all the data for the doctor? Or what if you could wear a Band-Aid that, like I was saying earlier, captures your heart rate? When your kids are sick, you're always worried that they're going to stop breathing in the middle of the night. So you have them in your bed. What if you could just put a Band-Aid on them and, you could hear about it? But it wouldn't be like, I have to make a, $500 or $1,000 commitment in order to know that. And I also just throw it away when I'm done.
Yeah, no, that's exciting. And that's kind of gets to the next line of questioning about, who do you see yourself licensing this to companies like, a paper manufacturer, for instance, or, who will be the manufacturer of this type of thing?
So for the manufacturing, because it's so small, we believe that we'll be able to make in the millions of sensors in our own factories that we have today.
Okay.
I would say, obviously I don't know, who we'll do deals with and what kind of volume we'll need, but I would say for the foreseeable future, maybe 1 to 2 years, we'll be able to manufacture it ourselves in the current facilities that we have access to. At that point in time, when it becomes so successful or the demand is so big that it's more than a few million a year, then it's very simple to set up this type of factory, quote unquote, lab ourselves in an independent manufacturing. It's not going to be particularly expensive. So I think it'll be some time before we would need to have somebody else do it, even though I'm not opposed to that.
Mm-hmm. Yeah, I was just kind of curious if they're integrating it into their product, it might be kind of handy or whatever, I suppose.
Correct. Right. And that would then be, there's no reason why not to do that. And certainly in the manufacturing of devices, that would be, predominantly for them to do, and we're providing the sensors. And maybe when it goes so well, they also begin manufacturing them as well.
So the manufacturing itself, I would imagine that's the challenging part, bringing this from the lab to something in volume. Are you guys close to that point?
I think we actually are close. So we have this beautiful relationship with the University of Washington. We license the IP from them. And they have a couple of labs that are affiliated with the University of Washington. One is paper, so it is actually making
makes
paper.
sense.
Yep, yeah, special paper nonetheless. And then the other lab, that process of taking that paper and making it into an automated process to create the paper, have the proper quality control, to cut it, paint it, wrap it, package it, and turn it into like a real quote unquote sensor. That's totally within our capability on an automated basis within the next 6 months at the most.
That's incredible. And so how are you guys funded then? Are you VC funded or?
So the IP group, which is a hard science driven company, has multiple relationships with universities. I think 6 universities and 3 labs now. And their business model is essentially to identify intellectual property in these facilities. They'll usually put a little bit of money into building a prototype to determine its addressable market size, etc. And then our company was formed. That IP goes directly into there. We sign a license for the IP directly with the university, and they put seed funding into the company for us.
Excellent. So then the plan is to introduce it at CES. Is that the kind of the idea?
Yeah.
That's great. So we're getting a scoop here, kind of.
Kind of, actually, you really are, because when you launch a company, I mean, I have a lot of contacts on LinkedIn, and I had a lot of really, including you, a lot of really wonderful, feedback and so forth. But it takes time. You launch a company, and it's sort of like a tree falling in the woods to a certain extent. We did, got a couple of good articles out there. We've had a lot of attention, but it's early days.
Well, that's very exciting, and it's so exciting to just see what you're doing and how it could be so game changing in so many ways. And Barbara, I appreciate you coming on this morning with us, and look forward to hopefully to seeing you at CES.
Yeah, thank you.